This video is on dot products. The dot product of two vectors v equals a comma b and u equals c comma d is the sum of the product of the horizontal components and the product of the vertical components. We use a solid dot to denote dot product. See below, we have v dot u equal to ac plus bd. So what do we mean when we say the product of the horizontal components? So in our generic vector v, we have a horizontal component a. Remember, that's in the x position. And we also have a horizontal component of c, which is in the x position for u. So the product of the horizontal components is a times c. The product of the vertical components are those in the y positions. So we have a b and a d. That's a b times d. And we add those together, and that is our dot product. Let's do an example. Find the dot product of vector v equal to 5, 12 and u equal to -3, 4. Remembering, the dot product of v and u is the product of those horizontal x positions and the vertical y positions. So here we write this out step by step. v dot u equal to 5, 12 dot -3, 4. This is our v, this is our u. Now let's take those x position, and we've got a 5 in the x position for v, and we've got a -3 in the x position for u. We have to add this product to the product of the y positions, 12 for v, 4 for u. Multiplying 5 by -3 gives us -15. 12 by 4 is 48. We have to add them together, and we have a dot product of 33. And we want to find the angle between two vectors sometimes. So we'll use the following formula. Cosine of theta equals v over the magnitude of v dot, as in dot product, u over the magnitude of u. And what do we mean when we say angle between two vectors? Well, let's take a look at this. Here's our xy plane. We have some vector v over here. We have some vector u over here. And there's an angle, theta, in between those two vectors. And that's an example of what this might look like. Let's do an example. Find the angle between vector w equal -3, 4 and vector z equal 5, 12. Step 1, let's find the magnitude of w. So we take the x coordinate of w, -3, and the y of 4. We square each, add them together, and take the square root for magnitude. -3 squared is 9. 4 squared is 16. Add them together, we get 25. Take the square root, magnitude w equal to 5. Second, we find the magnitude of z. And we've got x is 5, y is 12, 5 squared is 25, 12 squared is 144. Add them together is 169. Take the square root, and we have magnitude z is 13. The third step is to take the dot product of vector w over the magnitude of w, that symbol for dot product, vector z over the magnitude of z. We want to write this out step by step so that we can keep everything straight in our minds. So the first step is, what does this say exactly? So we take the vector w, -3, 4, and we place it over its magnitude 5. right here. Keep that dot product symbol, and let's take the vector z, 5, 12, and place that over its magnitude. Now we have an idea of the numbers we're working with. So we take the product of the first values plus the product of the second values. The first value for w is -3. We want it over the magnitude, that's 5. We're multiplying, notice the change in symbol. We need to find the first of z, 5, over the magnitude of z, 13. Now we add, and we move on to the product of the seconds. So for w, we have 4 over 5 times, for z, the second is 12 over 13. Let's do that multiplication before we add. When we are multiplying fractions, we can multiply straight across. So we have -3 times 5 gives us this -15. 5 times 13 is 65. Keep that plus sign. We'll combine it in a second. 4 times 12 is 48. 5 times 13 is 65. Now we're adding two fractions. We have to make sure we have a common denominator, which we do. It's 65. Denominator does not change when we're adding. And we just add the two top components, the things in the numerator of each fraction, which is +48 and -15. And that gives us 33. So the dot product of w over magnitude w and z over magnitude z is 33/65. Lastly, we find the angle. This is our fourth and final step. Remembering that theta equals the inverse cosine of the dot product of this w over magnitude w and z over magnitude z. Well, we already know all these numbers, and we did the work above, so we plug it in. We have theta equals the inverse cosine of our dot product, 33/65. Plug that into the calculator, and we have 59.5 degrees for our theta. Remember, if your calculator is set to radians and not degrees, you'll get a different number than 59.5 degrees when you enter this in. Let's take a peek at what this might look like. So we had that vector 5, 12, that was our z, and then we had our w, -3, 4. They're in standard position, so they both start at the origin. We use those terminal points to identify where the vectors end. And what we're trying to do is find the theta in between the two, and we got that to be 59.5.